So I'm Yves. I work for a Belgian company called Spikes. I come from Belgium. That's not really interesting. I have two rules when I give talks, which is not something I do that often. But if at any point in time you want to leave, please do so. Don't feel any obligation to stay in this room if you think that something else is more interesting than staying here. I see a lot of people doing that, but you have explicit leave to do it. Just do it quietly, and if you're the last one to leave the room, you stay. Because otherwise it's kind of interesting. There is this Slido thing. If you go to slido.com and you do #LT, you can ask question, but I will probably lose track of this. So just raise your hand and shout your question at any point in time, because in systems I build, I like this kind of unidirectional dependencies and information flow, but this does not work with humans, so please interrupt me at any point in time. Okay. I'm Yves. I said that I build line of business application, the boring type of lines of application. You know, it's like least detail, I have works to do, and I work for government, which is even more boring. Or so they say. And I'm currently working in the human resource part of an agency, and we manage selections. So people who want to work for the government in Belgium, they have to go through some kind of selection, they pass tests, and those could be selections that range from 5 people for management functions to 5,000, 6,000. I think the max I've ever seen is 10,000 people applying for more than one position, of course. It's like one of the biggest I've ever seen. And if you want to find me online, I'm Ylove, and I like the Y in my nickname, because that's the reason I'm doing this talk. In even source system, latency is feared by the developers, and eventual consistency is totally unacceptable for business. That appeared on a Slack channel. If you're interested into even sourcing and so on, the slides will be on there, but there's a really cool place you can go to. People are like responding to questions and everything. It's very active, and we forget everything after 10,000 messages. So you can say silly things, it will get forgotten. So that sentence here, I don't know who put it that, but I just stopped thinking about that time, because this is so wrong. First, let's see about latency. Let's get something out of the way. Anybody, I ask questions, most of the time it's like you answer yes and I'm happy. Not this time. Anybody knows what this is? Background radiation of the universe. How old is that? 18 billion years. We discovered that by accident in the year 50s. So, if you feel latency in your system, I have a good news, there is an upper bound, 18 billion years. So one day you can go to your boss, and if your boss asks how many time is this going to take, maximum, just say 18 billion years, because you can't go past that. Yeah? Okay, that might sound silly, but latency is something that exists everywhere. I mean, the universe is, the signal we get from this background radiation are so old. It's in every system. Every system has that. It's a fundamental property of any business process, of any company, of your daily life. It's not something to be feared. It's something that you need to manage. And mature processes deal with it. And in the context of this talk, I mean mature is business processes or companies or organizations that take that into account into their system, into the business. But I'm into domain-driven design, by the way, so I like words and I like definitions of words. Anybody has a definition for latency? It's not a yes, no, but just raise your hand. There's no wrong answer. Oh, come on, help me. I'm going to wait until you answer. That's latency. I send you a signal, and I'm waiting for an answer. And unfortunately, I have to kind of have this upper bound. I cannot wait for an hour that you answer, so I will give you the answer. That's a Wikipedia answer, because Wikipedia is a source of truth. It's a time interval between some stimulation and some response, and the delay between the cause and effect. So, latency. I told you there is an upper bound. So if you look at your system, if you look at your business processes, there's two things that you need to do. What is the upper bound? What is acceptable for the business? You need to define that. And I'm not talking about the number of requests per message. I'm talking about the business processes. Number of the latency between a request and a response in some kind of HTTP communication is important, and you need to define that. But those are purely technical stuff. That has to do with what the business finds acceptable. So you have the upper bound, which is what the business finds acceptable, but we tend to forget to, when we optimize system, we need a lower bound also, where we will not optimize further, because it's totally not worth the money. So two things. Okay. I work in HR and government, and we have something like the mailing list. You have a mailing list. It's not a mailing list. It's 500,000 mails, custom mails sent to every candidate that we know of that are interested into getting a list of job. Think LinkedIn, but small. Yeah. Oh, job for you, job for you, job for you. So basically, the mailing list is like this process, and we're matching resumes against some criteria on the selection, and then you get a list of selection, and oh, this job, you can apply to it. So, quick calculation, we have about 500,000 that we send every week, and we have about 40, 50 selection open at all time. How long does it take just to compute for this person? I'm going to show this selection, and this selection. This is kind of shameful for me how long that takes, but make a wild guess. Those are SQL queries, by the way. 2 days. 2 days. Because it was built on top for something that was not made for batching. And it's 2 days. Do you find that problematic? It depends on the low bound. Actually, it's not problematic, because the mailing list is not something that we have to do. Actually, we solved it. They pushed something in production yesterday, so Monday we're going to see at the exact time that we saved, and I hope it's an hour or something. Should be an hour. And it's like 2 days, and it fails, because if something runs for 2 days, we have on-premise system, it's government. Well, yeah, things break during the weekend, because there's no one monitoring them during the weekend, or they don't want to monitor it. But it's not a problem, because it's not a business issue that thing from time to time fails. So we don't optimize it. We did it because it was beginning to get a problem. But this government agency is actually responsible for publishing all the jobs that are open. The mailing list is not part of that publishing process. That's not something that somewhere there is a rule or law or some kind of regulations that say, and you have to do the mailing list. We just have to put that on the website. So I'm more interested in having the website having good latency property than the mailing list. And so if I have a problem, I have to choose between the two. We have 5-man teams, we have lots of systems, so we need to prioritize. This is low on the priority list. Okay, we're also talking about eventual consistency. Someone can tell me what eventual consistency is? Okay, who has an event source system in production to, oh, no, sorry, let me rephrase that. Who knows what event sourcing is? Quite a lot, cool. Who has an event source system in production today? Less. Okay. And funny thing is, people think it's because you do event sourcing that you have eventual consistency. Definition of eventual consistency? I gave you time to think. Oh, okay, Wikipedia. Eventual consistency is a consistency model used in distributed computing to achieve high availability that informally guarantees that if no new updates are made to a given data item, eventually all access to that. This is giving me a headache. This is, no, that's my definition for this talk. I have one part of my system who has a given state on a given entity, and I have another part of the system who has some information about that entity. It's modeling the same thing, but has a completely different state. Let's say I have a system that should make Alexi here happy, and there's this system who thinks Alexi is unhappy, and there's that system that thinks that Alexi is unhappy. And again, it's everywhere. It's not only in even source system, it's in every system, in every processes in the universe. Because there is no central control, or if you design something with central control, we have like a problem. Think of your body, it's eventually consistent. It doesn't know what it's doing. And again, mature businesses deal with it. Hello. This is what I mean by mature. About 20 years ago, there's a new law in Belgium that appeared. It's called Loi Renault, Law Renault, and there was this car factory, and they laid off like everybody, 3,000 people, direct. I'm not even talking about indirect consequences of that. And what does that have to do with eventual consistency? I'm this factory worker, and I have a job. And I go home and I have a job. But the fact is that a few days before, management decided we are going to lay off everybody because we are going to move the factory somewhere else. That's eventual consistency in that system. It's the view. You don't have a job. I have a job. Day later, I get this letter. What the government did is put some rules about it, because they can't do anything about collective layoffs, but they can put rules that manage the process of this layoff. That means that if a company wants to do a collective layoff, which is a number of people, a certain percentage of the people who work for you, you have to follow some rule. So that law manages the consequences of eventual consistency, the fact that actually the government doesn't know that there's going to be a layoff. Make sense? Yeah. Okay. No, not bank account, leasing. I worked in leasing before, and automating decision, and where is eventual consistency in there, is got some leasing request. Orange, should be orange, is an event, something that happened. This is some rules that are being applied, and this is, again, events, business facts, event source. So I have a leasing request. It goes to some kind of system, and there's only three things that could happen. It's you get the leasing is denied, the leasing is granted, and undecided, which means a human being will look at it. So the purpose of that such system is maximizing those two, minimizing this one, so they can lay off and then fall under Loi Renault. Okay. If you look at, can you see that in the back? Or do I have to zoom? Yes? Okay, if I look at this leasing request, what is used in this rule system over there, we have annual accounts. That's something that is taken into account. We have ratings, we have commercial analytics, things Dun & Bradstreet, grade on, and we have obligo, how much money do they owe us. Those are typical things that happen. And first time I built that system, it's like this annual account, every company needs to do that. It's sent to the Belgian Central Bank, and you can ask him, and you get the numbers of the company. And one day I got a problem because, and that's the last line. Can you see that in the back? No? I tried to zoom, but okay, I'm gonna say it. If I put a timeline, there was 1 year ago, the annual account, was published, and then we had a problem because there was a correction of this annual account. So at that point in time, I was asking, okay, give me the annual account, and I don't get what I expect. This is purely a delta of what's happening here. And this causes problem, and this is interesting, because if you take the same company, It's about eventual consistency. And you would do like, follow those rules on accounts published 1 year ago, or the accounts were published 6 months ago, or the accounts were published 1 day ago. You don't get the same view of that company, because those numbers are, by the way, about a year ago. So you don't have the real financial situation as of now of the company. Those could be really good numbers 1 year ago. Tomorrow they might be bankrupt. And I said, mature process deal with it. Mature businesses knows about the eventual consistency. That's why they have these other items that they take into account. The statistical analysis to build those rules and the cutoffs of, okay, we are going to deny it, or we are going to accept it, or someone needs to look at it, is taken into account with the bank rating, because the bank has even more information about those companies, and in the commercial analytics. The gradients, the Dun & Bradstreet, they are used to keep up to date with the financial situation of that company. So that's taken into account into the system, into the business, actually, the rules that they have about when do I accept or deny. Make sense? This is just to prove that business knows about their problem. And final example, the talk abstract. Everybody read the talk abstract, I guess? Did I talk a lot about my domain yet? No? Do you know if I'm going to talk about my domain? No. I had a completely different view of what I was going to say a year ago than today. I'm saying different things, but the abstract didn't change. I do that on purpose to show how, what can I do about that? And actually, I managed that problem, that maybe this talk is not what you expect. I gave you leave to leave. Doesn't mean I'm mature, that's not the issue there, but I'm managing. So, latency and eventual consistency happens in all systems. Even, that's due to a discussion with someone a few weeks ago, even if your system is database driven. Do you think you have eventual consistency in your database-based application? You need to say yes. Because I get a form, and then I lose connection to my database, and I'm one guy, and I'm editing some entity, and then there's another guy editing the same entity, saving there, and I'm making a decision on outdated data, which is all about eventual consistency. And I'm not even talking about things like, actually the database, that's your legacy system, and there are 5, 6, 10 applications who are using the same database, the same data, and completely messing things up. So how do we deal with that in such system? Anybody? How do we deal with eventual consistency? There's one simple trick that everybody knows. Yeah, that's the simplest one. Of course, transaction is one thing, but if I have data and I saw it already, yeah, my transaction is not going to. But optimistic lock is one way that we deal with it. And what do we do with optimistic lock? We, again, show the user, oh, something has changed. You need to redo what you just did. There's also pessimistic lock. That's perfectly valid in some cases. And serializable transaction if you want to lock everything. And again, think about what happens if your database is shared. So that's just to refute that first sentence in Eventual system. No, it's in all system. And you know already today how you need to deal with that kind of problem. So the only thing we can do is cope with it, and people fear it because when you're talking event sourcing, you take time into account, and you will need to have discussion with business about latency, about eventual consistency. You're not going to use the terms like this, but you're going to do that in terminal with the business and how they actually work and deal with edge cases. And there are two things that we can do. I can try to minimize the consequences. That's the example of this law. I minimize the consequences. I cannot avoid it, so I need to minimize the consequences, or I can minimize the chance of happening it, pessimistic lock, or having a really fast system. So, CQRS, anybody? Yeah, thank you. Of course, we build systems. We have this problem about latency and eventual consistency that is built in the business, that's there. But when we introduce technology, we also introduce the same issues, but due to the design of our application. Okay, just to make everybody on the same level as me, making you consistent with my idea of CQRS, this is CQRS, that's it. I have some user, it might be an application. I have models for querying my data, models for mutating my data. They are separated and easy to handle. And I go to some kind of data store. That could be a database. You can do CQRS without event sourcing. But if you are using event sourcing, we are introducing a few things with our CQRS design, is that my query handler will populate some data that comes from my store. My command handler will work almost directly to my event store. And if you're doing event sourcing, there's one question that always pops up is that I have entity A and entity B, and they need to know about each other, and there's a relationship between them, and when this happens in this entity and that happens in that entity, then this needs to happen. So those two entities need to talk to each other, and which is something that we don't really like because that's coupling. In event source system, you can have something in reactor, call that process manager, saga, whatever, but you can have something that reads everything from your event store and reacts to things happening on the whole data that you have. And you can optimize stuff there, and probably also will talk to external systems. So if you want to do event sourcing, don't forget the last one, because there's not a lot of people who talk about this thing that you can use to manage some problem about, yeah, I need to know about more than just one entity. So where do we introduce eventual consistency or latency? Is first you don't, because from the point of view of your API or your web UI, maybe I'm going to be different than you, is you don't. Those are synchronous calls. And by synchronous, I mean you get kind of request response. There's no queuing involved. You might do async, that's not a problem, but there's no queuing involved from this side of the picture. You might need queuing, but if you don't, if you introduce it beforehand, you have a problem because you have to manage your queuing. And you have to manage the fact that your queuing system is going down, that it's going to fill up, and if you don't need it, you don't need it. Where do I have eventual latency and eventual consistency? Here. Because I have like those command handlers, they are emitting events all the time. And those need time to catch up. This is where I have eventual consistency on my read model. And I need to manage the latency over there. Oh, but I also have eventual consistency because the same problem as my database application. I have two people working on the same entity and doing stuff. Well, we use optimistic lock. So if you want to use an event store, you need something that will allow you to have some kind of optimistic locking over there. And the last part, that last one, that's reactor, is also eventually consistent because it needs typically to have all the events coming in, and there are multiples of them. They are really business focused, some kind of route specific stuff that needs to be done. And this is where you're going to have typically also some eventual consistency happening. Yeah? Promise to talk about my domain. This is I'm going to not scratch the surface, I'm going pretty deep, so you have to try to follow. So I'm in HR, and we have selection process. And in those selection process, it typically, looks like this. I have three-step selection. It's first people enroll, of course, they choose a date, and they have some kind of generic test. We do psychometric tests, we measure competence, dimensions, indicators, and motivation, and verbal reasoning, and stuff like that. And those are generic tests. Everybody does the same testing. Then we have job-specific testing, on PC, and then if you're successful, you go to interview. And actually it's a gigantic filtering system, if you look at it. Because if you have, like I said, 10,000 people enrolling, you cannot have 10,000 people on interview. That's not possible. So we filter people out. And since everybody is doing those generic tests, everybody takes the same test. There's some differences in, depending on the job, how we measure or we give you results. You have like 10 on 20 or 80 on 20. You could have the same responses, but there's some different ways to calculate it, depending on the type of job. And since everybody takes those tests, we need to grant exemptions. If you pass the test within a certain time frame, you don't have to pass them again. If you fail the test, you can't pass the test within a time frame. That's one way to get exemption. You go directly to the step 2 of that selection process. There is another rule, another type of exemption, which is the one I'm interested in. If you already work for the government, they assume you're good at it. You don't have to pass the test. And the problem that business has is we actually don't know who works for the government. It's really difficult to know. We can know who works for the government, but we don't get enough data. There's missing information in there. The best source is, of course, asking the payment system. Oh, if you pay them, they're probably I'm going to say all the time public servant because that's a word I use. The correct word in English is civil servant, but I'm sorry about that. So we get information from the payment system, but that's not enough information. That's not enough information. It doesn't have all the information we need. So basically what happens is that candidates, they go on the website, they fill in their resume, and they say, I'm a civil servant, I work for finance. Since that date, I have a proof of it, and we give an exemption, we believe him. Or we get some information from some other system. And that, the fact that it's a candidate that tells us, I'm a civil servant, we need to check that. We need to verify it. And so they have two problems that need to be solved. Query side, I'm looking at the query side, is how much of those resumes do I need to verify on that information, and which one do I have to verify? We have 40, 50 selection running all the time. There's actually more running in. We have selection assistant needing to manage like 40, 50 selection in all kind of stages, and they're overworked, so they need really task-based. How does that look up? This is an actual screenshot. That's really simple application. That's how much work do I have? How much work there is, actually. Okay, there are 800 resumes to screen. And what do I have to work on? That's my selection. I click here, I go to some detail page, I verify the information, and I confirm if you're a civil servant or not. Okay. So if I look at it, okay, they can enroll, and the CV check is checking the resume and checking the information you give. I have this step 1, and if I'm succeeding in step 1, your resume will be screened because I'm not going to check every 10,000 people there. There may be 5,000 people who succeed, and of those 5,000 people, I need to check 100. So we do resume screening like, is he really a public servant if he had this exemption? And then the rest. Yeah? if we talk about time, latency and eventual consistency is about time, you need to draw a timeline. And once you do that and have discussion with the business, you would see interesting things happening. Is that actually those are not like done. They are overlapping. There's this step 1 period. That's when people can take tests. There's the last day of enrollment. It's the last day you can enroll for that selection, and then you can choose testing there. And they begin resume screening. And through discussion, they normally begin on the last day of enrollment. So they might be screening people who will fail eventually. And okay, it's sometimes overlap the second period. This is problematic for the business. Why? Because I might be enrolled here for a test. I need to do a test tomorrow. And today they screen my resume and they say, no, you can't participate. Or you have an exemption, so I'm already enrolled here, but oh no, you need to do this one. But what happens if I take this decision here or here? The effect on me as a candidate is different. Yeah? So that's one visualization, but it's not enough. We take a wall, we take stickies, and we have at work like this kind of wall. And when we did this exercise, you might multiply by 5 the numbers of stickies over there, and you lay out all the events that can happen. That's a trick. That's one trick. So I have the CV checked. I'm enrolled. Those are events. I'm event sourcing my system. I have my exemption strategies over there. The back, it's all right, or do I need to zoom? Say yes. Yeah. Okay. That's the maximum zoom I have. So I have my CV check, enrolled. That's one timeline, one candidate. I have my exemption, and I have an exemption granted. Everything is all right, cool. And then a bit later on, you have to think time is flowing. I change something on my resume. My resume is my legacy system, and we just do change data capture, like something has changed. So we need to re-evaluate the exemptions, and I might lose my exemption. This first step, I need to do it. Another case, and there are more than what I'm showing actually, is I just filled in my CV. We give the benefit of the doubt, yes, you are a public servant, you get your exemption. But since we didn't check anything yet, there's a human decision that is needed. We're going to say who and what selection, so that we can answer how much work do I have, what is the exact word do I have, and there's one of 3 things that had to happen. I'm a public servant, I'm not a civil servant, I'm not a civil servant, or I'm a civil servant but not on federal level. Because Belgium is complicated. And when that happens, there is this confirmation. Someone from the business checked. We reapply the rules, and you might either lose your exemption, or in the real world, we say exemption is granted, and it's an idempotent operation because it doesn't change any state. Okay. Another possibility, I have been granted an exception. I have a human decision that is needed, so the business will need to look at it. I change my resume, so the business thinks, oh, I need to change something, and something changed in the CV. I have my exemption strategies, and I lose that exemption, and then suddenly business has less work. Following? Okay. So I need to answer still those questions: how much work, how many work, and those are duplicate side. Now, I have this big wall full of stickies, full of all possibilities, things that can happen. And what happens if I move this on the, and 30 square meters full of stickies. And what I mostly do then is looking at dependencies. But if I remove everything and I look, oh, I have a read model, how much work, and I have a right model. What work do I have to do? And I look at what is the information I actually need to be able to build those query sites. Okay, I need to know that there's a decision needed. How much work do I have? There's some kind of decision. And then if I have, okay, you are confirmed as federal, you're confirmed as non-federal, or you are confirmed as you're not a public servant, civil servant. That's all from all these stickies and so on, that's my dependencies. And those lines is, to build this query model, I need 4 events. And that's a tremendous amount of lines. That's too much for me. So one little trick, I'm splitting things. I still have my human decision needed, but what I'm doing now is, what do I have to work on and how much work do I have? I really don't care what the decision is. I need to know that a decision was made. And suddenly I have my 2 query sites, they only care about 2 events. And it's quite interesting because what I can do now is add new types of decision. As long as I have a decision is taken, those 2 don't ever need to change. Making that a bit more explicit, I'm drawing boundaries around what I need. But the architect said, I'm not the architect, this must be even source, so I need streams. And if I look at my stream, this is one thing I could do. I could have like public servant information, John, and there's lots of information over there, and I will have my federal public servant confirmed. Maybe later I'm not a public civil servant anymore, and then I'm confirmed again, and blah, blah, and blah, blah. And I have all those streams with all the decision made about, is this person working for the government or not? Plus other information that we don't need. And I have one stream with all the decisions, with the fact that the decision was needed and the fact that the decision was not needed, one stream. And I can begin to optimize this one. The reason why we're even sourcing is that we need correlation around stuff, because people complain and complaints, they are formal, it goes to, could be that we need to invalidate a whole selection. Things go to court from time to time. So we need to be able to explain at any point in time why this happened and why this person lost his exemption or not, or got it, and why this one and not this one. And if you're even sourcing your system, you can correlate. I have this take decision, the command in my system. I can correlate it to the fact that there was a human decision needed, that it was this decision that was taken, and that the actual decision was on another stream. So this is just to get, okay, how this correlation between my stream exists. Yeah, makes sense so far? Something lighter now. That question popped up on Slack or in a meetup. And that's one. Someone has a question? I see an arm. No? That could be. Username must be unique. Again, I have an architect that wants to even source everything, even the user registration, which this is an exercise. Don't even source your user registration system, use what you have. Probably the stack, the framework, whatever you're using has some kind of user registration, it's going to as well. And this is a brand new application, and this is the first page that you see, and I cannot do anything because the system is empty. The only thing I can do is choose a username and try to register. And that username must be unique. In reality, it's going to be username, email, we send a confirmation. That's not actually the only thing I can do on the website. I can accept the cookie policy, which is my rant of the day, because I don't know if you've noticed, but a lot of websites are putting those cookie policy on the buttons I want to click. And this is really annoying, really. And how would you do that in a classical way? Database is enough, yeah? I have some kind of table and I have a primary key username. Ensure uniqueness of username, yeah? Cool? What happens is I have that's one of the reasons I like to even solve my system is actually you have these two tables and you know that it's going to grow until an unmanageable state with your ORM. So let's do the exercise of looking at things in a temporal fashion. Let's put time in back. I have my big empty wall. My system is empty. I'm looking at command side now. And I have a command, register John. It goes to something that, naming is hard, so I just put that sticky over there. Something happens that will check that the username is unique. And it's easy, this one, John registered. Why? My system is empty. If you go a bit later on, what can happen afterwards? I have register Doe, check the rule, Doe registered. Yep. John register John. John was registered. Register Doe. Doe was registered. John, another John wants to register. And what is the output I expect from this? Is John already registered? Please choose another username. Okay. Again, I'm just going to look at dependencies. What event from the past? This is the state of my system, by the way. What event from the past do I need to check this? None. There were none. What system of the past do I need to be able to perform this this check? I need the fact that John was registered. What do I need to know if I can register John? I need to know that Doe was registered, and I need to know that John was registered. That's how I need to do. Okay, I have a question for you. Is this useful? Thank you. Thank you. What did I model? I took time into account, like I have my empty system, and adding things and trying things. I modeled insert primary key violation constraint. Actually, those two models are exactly the same. This or this is the same thing. I did not gain any insight. That's one trap if you're taking time into account, is that you don't gain new insight. You need to do that kind of exercise to get a new view on your system. One of the tricks, that's one, I'm going to zoom again maybe, is everybody knows reservation pattern. That's one trick that you can use. That's one implementation that we came up at that point in time. If I would do that exercise, it would be completely different. Instead of having one command, register John, I make two of them. Claim the username, register the user, make his profile. And result of that command is, he's registered, here's a profile. I need to check the username uniqueness. Username is claimed. Yeah, cool. Claim username Doe, same as before. Doe, two commands. But Doe does not reply to the mail. It does not confirm, it does no confirmation I want this account. But we have a profile for him because he filled in more information, of course. And then I have John, another John trying to claim his username. John was already registered, but I can make a profile out of him. This is cool for GDPR stuff. Huh? I know stuff of people who aren't in my system, actually, not using my system. And again, another Doe who wants to claim a username, and he got it because the other one didn't respond in time. Yes, you have 10 minutes. Yes, that should be all right. Again, if I look at dependencies, I didn't make it explicit, but actually in all this system, the only thing I need to know if username was claimed is one event, the fact that John was claimed. Yeah. Again, drawing boundaries around things that seems consistent, seems to work together, is that I have a lot of user profiles, and I have one thing that is managing this uniqueness. How do I translate that to streams? I have profile, lots of events, and I have username must be unique, which is the name of my constraint. Username claimed, username claimed, username claimed, username claimed. Cool. Okay, what's the problem with that, if I even source that? No, because I have one stream. There's one stream. I read it. What's the number one question that people who actually have a system in production, what's the number one question you get when you explain what event sourcing is what happens if you have 10,000 of events? You need to read them. Oh, build a read model for it. Yeah, but my read model is eventually consistent. That's not going to work. Oh, build a snapshot. I'm bringing in complexity. I have to manage that snapshot. I'm going to end with that. Use that database. You can have your unique constraint. I mean, I could have tens of thousands of millions of rows. If I cannot make that very fast on my database server, I guarantee that you are going to have problem with the rest of the system. If you cannot manage an insert statement in one table, in one row, and get it fast, you have other problem than event sourcing and eventual consistency. When people say event source system, you don't need to event source all your system. Of course, they are talking about complete part of the system. We are also talking about specific part of the system. In that case, that SQL query, insert, 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 is enough for the need. Yeah? Make sense? No, but on day one, yeah, but I need to know everybody who's registered.
Yeah, but you don't have a history of when you change the username or when you change it.
That's on his profile. I don't care. Yeah.
I concur with the guy at the back. So,
yeah.
Like, what happens if username eventually will become not unique, will manage it, but the chance of it to happen is so small.
Yeah.
They can ignore.
That's the point. This is purely an exercise, but it brings that kind of question when you do that exercise. We can discuss that later. I don't have stickies. I would like to have that with sticky. Somebody has stickies with him? No, I'm not doing that. Okay, so basically, latency, fact, eventual consistency, fact, you have to deal with it. And just model time, because if you're talking about latency, just draw that line, draw that thing, and try to come up with different models than just insert, update, because you're not gaining insight. Try different things, try different models. What happens if this happens? What happens if I split event? What happens if I split streams? This is going to get you insights and allow you to do optimization in very specific places of that subsystem in your event source system. Yeah? If you're new to all this stuff, buy those 2 books. Messaging, the first one, it's old, it's still relevant. And the one from Greg Young about versioning event source system. It's free online, but buy it because it gives back to charity and for Code Club, so teaching kids to code. That's it for me. Thank you.